Yes, welcome to DC Economics. Today I'm going to take you on how to solve correlation coefficients and regression. Correlation coefficient is a statistical measurement of the relationship between one dependent and independent variables. So this means we measure the relationship between x and y variables. So there are types of correlation coefficients. We have almost 3 types of correlation coefficient. The first one is the positive correlation, and the second one is negative correlation, and the third one is no correlation. So positive correlation is a type of correlation whereby two variables tend to change together in the same direction. For example, x and y, x independent variable and y dependent variable are moving in the same direction. So positive correlation is described into two forms. We have the perfect or strong correlation, and we have weak positive correlation. Perfect strong correlation is whereby R is equal to 1, and weak positive correlation is where you solve out the R correlation coefficients happen to be less than 1, or it sometimes happen to be a positive less than 1, or can be 0.88 or 0.56. So here is the graphical representation of positive correlation. In the left hand side we draw the graph, whereby in the left hand side we have what is known as y dependent variable x and the x-axis. So we actually observe y and x moving in the same direction. The second one is negative correlation. So if the two variables are changing the opposite direction, that is what we actually refer to as negative correlation. There are some forms of negative correlation. We have what is known as perfect negative correlation, and we have what is known as a weak negative correlation. The perfect negative correlation is whereby R is equal to -1, exactly -1, and weak is whereby R is less than -1. Third one, we have what is known as no correlation. This happens that there is no any kind of relationship between x and the dependent variable and the dependent variable. So we actually observe to see no any changing or moving direction of the two variables x and y. So we can draw the scatter plot like this, whereby we observe the scatter plots are not organized at all. So there is no correlation between x and y variable. So this implies there is a negative. There is no any kind of relationship between the variables. So let's look on formula for how we calculate the correlation coefficients. Is whereby we take correlation coefficient R is equal to number of observation times summation of xy minus summation of xy times y over radical number of observation summation of x square minus summation of x square times summation of y square minus summation of y raised power of square. So that is the formula of how to calculate the correlation coefficients. So you may ask yourself, what is n? N is the number of observation, and E is the summation. Now let's look at an example. The following data gives the numbers of football jerseys purchased at several places. So we can observe the table like this. In the upper side of the table we have what is known as the price of the jaws, that is presented by E, and we have in the bottom we have the number of jaws demanded. In the upper side we have 6, we have 10, we have 14, 18, we have 20. As you can observe, we have 142, 85, 96, 44 and 40. So you are required now through the question to plot up the data Q against P on the scatter plot diagram, whereby our Q is what we refer to as the number of jaws and the price of jaws. Also B is to calculate the correlation coefficient. So the price of joules we observe and the number of joules are there, where the price of joules is E and number of joules is Q. Then after that, we are required now also see to the slope of the least square lines were calculated like this. The question number C, the question C is actually the slope of the least square lines were calculated as negative 9.6 and intercept bars, that is 23.1.7, that is beta naught. Now we are required to write out down the equation of the least square line. Now we're required to write down the equation of the least square line, and also to calculate the numbers of joules purchased when the price is $15 when the price of joules is 15. So let's go to solution. Now remember, the part A, we are required to plot out the data Q, that is the number of joules against the price of joules on a scatter diagram. So Q, this is where I represent the number of joules, as I told you. P is the price of joules. So Q is what will represent out Y, and P is what will represent out to the x-axis. So from our table that was on a horizontal style, we change it into a vertical style like this. So we have the price of joules on the left hand side. So we sketch out x and y, whereby our x represent out on that figure on the left hand side, that is 6. That is the price of joules. We have 6, 10, 14, 18, and 20. But also we sketch out the data, and we plug in the data for y, where is these are the number of joules demanded Q, that is 142, 185, 96, 44, and 40. Now let's draw now the graph. We have the y-axis and the x-axis. So we determine the highest value and the lowest value, so as we can actually set out our scale for this graph. So we have also the y-axis as you observe, and we have the x-axis as you observe. Now let's plug in our numbers, starting from the price of joules and the number of joules. So we have 2, 5, 4, 6, 8, 10, 12, 14, 16, 8, and 20. And the y-axis we have 20, 40, 60, 80, and 120 and 144. So we have used a scale of 20 by adding 20, and we have used a scale of 3 in the x-axis as observed. We use a scale of 2, and here we use a scale of 20. So we sketch out 2. We sketch out 60, 142 as you observe. We sketch out 1844 at that point over there. So as you can observe, the scatter plots are in that direction as you observe. So the scatter plots tends to show that it's likely moving on the upper side of this diagram. So when you try to look on the scatter plots, you can observe these scatter plots are like moving on the upper sides of the graph. Also, part B, you are required to calculate. So you are required to calculate the correlation coefficient. We have the data of x, that is 6, 10, 14, 18, and 20. And we have y, 142, 185, 96, 49, and 40. So we had another table for x square, but also for y square as well. So since we have the R, correlation coefficient, that is given by this formula over here. So when we had this table over here, we plug in some data. We find the total for x summation and total summation of y as you observe. So this will give out, take out 6 times 142 will give you out 8 and 52. It will give out 8 and 50. Now 14 times 96 is 3 and 44. And the same applies, there is 792 and 800. So we square x, that will give 36, 100. Will give out 196. It will give out there 79. It will give out again equals to 400 as you observe. So from that data set, we take out the y square, that is equal to 144, and y square it we take out is equal to 20, 164. Follows one with last of 600,000. 16,000. So total summation of x is 68. Total summation of y is equal to 50. But also the total summation of xy, total summation of y is 507, summation of xy is 5638, but also the summation of x square is equal to 1056, but also summation of y square is equal to 6741. So we plug into our formula of number of observations, summation of xy, divided by summation of xy minus summation of xy times the number of observations, summation of y square minus summation of y square. So we plug in the number of observations, which is equal to 5. We times out, we take out 5 times 5638 minus, we take out some from the given data, that is 68. We times the 507. We divide by what is known as the number of observation again. So when we plug in, it should be 5 times 1056. Then you minus 68 raised to the power of 2 times 5 times we take out times 7 141 minus 507 raised to the power of 2. So the correlation coefficient will give out will be equals to, we take out the follows data that will give out, it will be equals to, correlation coefficient is equal to negative 0.8750. So that will be the correlation coefficient after dividing some numbers. So correlation coefficient is negative 0.8750, implied that the inverse relationship, there is inverse relationship between two variables, y and x variables. So correlation coefficient is actually obtaining from the general formula, as you observe, that we consider to take out the error, which is equal to number of observation times summation of xy times minus summation of x times summation of y, divided by the radical of number of observation summation of x square minus summation of x square times the number of observation summation of y square minus summation of y square. So let's go to require on part C, that is to require to write down the least square regression line. So in writing the least square regression line, we consider to know the slope coefficient together with beta naught. So the slope coefficient is given over there, whereby we have negative 9.6, as well as we have what is known as y-intercept, that is 23.1.7. So our general regression line will be y is equal to beta naught plus beta 1 x1. That's the slope, and beta naught is the intercept. And x1, this is the independent variable. That cause effect toward the dependent variable. So in this kind of equation, we actually write out the beta naught, which is equal to 23.1.7 plus the beta 1, which is 9.6 positive x1. So that is how it will be. So actual negative 9.6, that will be the what is known as the slope coefficient, and beta naught will be equals to 23.1.7. So 9.6 negative imply something on toward the change of dependent variable. Part D is to calculate for the predicted value of quantity of y when given x. So from the kind of data set, we are the price of Jaws that were sold at a given amount. So we need to predict out for y given x, which is equal to 15 US dollar. So the number of Jaws is represented by y, but the price of Jaws is represented by x. So when we calculate out, it will give out now y is equal to 23.1.7 minus negative 9.6 x1. So the x1, which is an independent variable, is 15. So when we plug 15, it will give out the y predicted value is equal to 87.7. So the predicted value, number of Jaws, that is number of predicted value, will give out the number of Jaws purchased when the price is 15 will be equals to 87.7. Remember to put out an HQ over on the top of y to represent out the estimated value. So the number of joules will be equals to 87.7 and a given price of joules, which is equal to 15. Now that is how actually what we do, and it is well solved and easy. Thank you. Welcome. I welcome you to DC Economics. Don't forget to subscribe my channel, and I welcome you to cross check on other favorable videos so as you can expand your knowledge. So bye bye.